Okay, so we'll see previous year questions on convection topic. In convection, I have listed out some of the questions which is asked in previous year question paper in different states for this assistant engineer post only. Now this first question based on convection, you see, I think it is visible to you, otherwise I will read you. With usual motion, the term Cp dot mu by k is called. So this formula, do you remember? In the dimensionless number we have seen the Prandtl number. What is the formula for Prandtl number? Mu into Cp by k. See this direct question. They asked you the formula question only. Cp mu into k is what number? Which is Prandtl number. Okay. I have also given the answers in the question. Right. Now according to Newton's law of cooling, the rate of heat transfer is, so what is the Newton's law of cooling we studied? Q is equal to HA into delta T. So here so many options are there. If you know very well the formula for convection, one governing law we have seen. What is the governing law for convection? Newton's law of cooling, which is Q is equal to HA into delta T, H into A into T1 minus T2, right? Next. The laminar boundary layer occurs when a cold fluid flows over a flat hot plate. The temperature gradient assumed as 0. So what is this? Something different. You have to now go for some theory thing to understand this question. Okay, so in our topic, laminar boundary layer is not given, but hydrodynamic boundary layer or velocity boundary layer or hydrodynamic boundary layer is not given in syllabus. But anyhow, this type of question we may expect, okay, related to boundary layer thickness. Thermal boundary layer thickness only available in our syllabus, but this question is based on velocity boundary layer. Just both are similar only. Just I will explain this question, you understand, and we take this question also, don't omit this question, right? Now what is given? The laminar boundary layer occurs when a cold fluid flows over a flat hot plate. The temperature gradient assumes 0. This is a thermal boundary layer thickness concept only, right? So what is given in our syllabus, that type of question only. This question is based on thermal boundary layer thickness, right? So do you remember that flow and the thermal boundary layer thickness, that flow diagram I have drawn? Again I will explain. So let us take this is one plate, right? Again I am explaining the boundary layer, thermal boundary layer, right? So this plate is at some temperature 80 degrees Celsius. On this plate a fluid is flowing over this plate. What will happen? The fluid temperature will be lesser than that of the plate temperature. So suppose let us take the temperature of the fluid as 28 degrees Celsius, which is flowing over the hot plate. What will happen? The boundary layer will form after some certain distance in x. The boundary layer will form. So that already we discussed, the layer which is adjacent to the plate will be also almost 99% equal to the plate surface temperature. So the fluid adjacent to this surface will be at same as the plate temperature. While you going up in this direction, then the temperature will gradually decrease, and at last it will become, the surface temperature of the fluid will be equal to 99% of the free stream temperature of the fluid. Okay, so after some certain distance, what is happening? Heat will not travel from here to after this distance. After some certain distance, heat will not transfer. Okay, so until some distance only, there will be some gradient in the temperature. What is the gradient? What is the temperature gradient? Temperature value will vary with respect to any direction. Now the temperature is changing in the y direction. Okay, so the temperature will vary from the beginning to some certain distance only. Maybe this is a 0 point where y is equal to 0, or you take this is y is equal to maximum. So when y is equal to maximum, where the y is maximum, on the bottom or top? Y is maximum on the top. Okay, so here only the maximum is reaching. Okay, after this maximum point, there will not be any gradient in the temperature. So the temperature gradient will become 0. Okay, so when the temperature gradient will start becoming 0 from the top. Now you see the question. What is I think you understood what I am trying to mean. The temperature variation will not be there after this point. Okay, even though the fluid is flowing over this flat plate, suppose fluid is flowing, the bottom layer only will be as same temperature of the plate, but if you come to some layer upside, then this layer temperature will be equal to the ambient temperature only. After this, maybe here up to here it will be some 75, 60, 50 like that. The temperature will gradually decrease and it will come to the free stream temperature. After this point, the temperature will not vary, it will be at that temperature only. So the temperature gradient will not be there at the top of the thermal boundary layer. That is the solution for this question. So the question is, the laminar boundary layer occurs when a cold fluid flows over a flat hot plate. The temperature gradient assumes 0 at top. That is the meaning for that. Temperature gradient will be 0 from the top point. The answer is at top. I think you well understood. Next, this is a problem based question. Air at 20 degrees Celsius. I think if it is not visible, so I am reading, you just understand what is the question. Air at 20 degrees Celsius blows over a flat plate of size 50 cross 60 centimeter at 220 degrees Celsius. Take heat transfer coefficient to small h is equal to 25 watts per meter square Kelvin. What will be the heat loss from the plate? So you think about that heat. Heat means in thermal point of view Q only. This is a convection problem. How I identified this is a convection? Because the heat transfer coefficient is given. When they give you heat transfer coefficient in the numerical problem, then we have to consider that as a convection problem. Okay, so this is a convection problem. So this convection problem, what they given? See, the H value is given. So I have identified this is a convection type of numerical. In that they are asking the Q. So what is the governing law for convection? Q is equal to H into A into delta T. Delta T is the temperature difference. So H value is given, right? Area for that they given 50 cross 60. This is a rectangular plate. So area L into B, 50 into 60 if you put, you will get the area of the plate. Then delta T will be there will be two temperature difference. Okay, delta T means temperature difference between the object and the surrounding. So Ts minus T infinitive. So Ts is the surface temperature of the plate, which is 220 degrees Celsius, and the air temperature is given as 20 degrees Celsius. If you put all the values in the formula, you will get the amount of heat loss. Okay, so that is the equation that we have to use and find out the Q. So if I use this equation, see, I substituted all the values. So I got the value as Q is equal to 1500 watts. So this much amount of heat is lost from the plate. Okay, so the answer is 1500 watts, right? Next, which one of the following non-dimensional number is used for transmission from laminar to turbulent? So Reynolds number, easily you can answer. The dimensionless number is used to find out the type of flow is Reynolds number. From laminar to turbulent, how to identify? By calculating the Reynolds number. If you see the non-dimensional number lectures of mine, where I clearly explained what is dimensionless numbers and what are the dimensionless numbers are there, in that we have seen about Reynolds number. Again I am repeating, Reynolds number is used to find out the type of flow, whether the flow is laminar or turbulent. So the answer for this question is Reynolds number. Next one, the thickness of the thermal and hydrodynamic boundary layer is equal if Prandtl number is equal to 1. When Prandtl number is equal to 1, then the thickness of the both hydrodynamic boundary layer and thermal boundary layer will be equal to 1. Okay, that is the answer. Then how many types of convections are there? Actually we have seen only two types, main only two, but one more is also there, that is mixed convection. So there are three types of convection: natural convection, forced convection and mixed convection. So there are three types of convection. Next, the Nusselt number is related to Reynolds number in laminar flow. Okay, so this equation we have already seen. In that equation we have seen that Reynolds number power minus 0.8 is there, but it is not given, so the answer is none. Okay, that equation I have given in the lecture videos. The ratio of molecular diffusivity of heat to the molecular diffusivity of momentum is what? So the definition for the Prandtl number which we have seen, the equation for the Prandtl number is given. Prandtl number formula equal to what we have seen. It is given as the ratio of molecular diffusivity of heat to the molecular diffusivity of momentum. But what is the actual formula? Molecular diffusivity of momentum by molecular diffusivity of heat. This is the actual formula for Prandtl number, but in our question you have to read it carefully. It is given as the ratio of molecular diffusivity of heat to molecular diffusivity of momentum. So that you have to remember the formulas always. You should not think always Prandtl number, what is the formula, then this is Prandtl number. No. You have to remember it properly. So this is the reverse of Prandtl number given in the question. So the answer is 1 by PR. Okay, PR means Prandtl number. The standard number also we have seen in the lecture videos. If you see, you can easily identify the answer for this. Standard number is the Nusselt number over the product of Reynolds number and Prandtl number. Okay, next, if x is the distance from leading edge, the thickness of laminar boundary layer varies. So A is 1 by x, B x to the power of 4 by 5, and C is x to the power of 1 by 2, and D is x square. This is the problem which is related to hydrodynamic boundary layer, where there is one formula. Hydrodynamic boundary layer delta is equal to 5x divided by root of Reynolds number x. So if you cancel this, then the thickness will be equal to root of x. So root x is equal to x to the power of 1 by 2. Okay. Then the ratio of thermal boundary layer to hydrodynamic boundary layer is equal to the Prandtl number power of n, where n is this actually delta h by delta t is equal to 1 by 3, but it is given in the ratio of thermal boundary layer to hydrodynamic boundary layer is 1 by 3, so the power is minus 1 by 3. Okay. Nusselt number is a function of, always it is a function of Prandtl number and Reynolds number. Okay. Suppose if they give Grashof number also, then you have to select this option also. Okay. That is the answer for this Nusselt number. Then a thin plate is at 27 degrees Celsius. The rate of heat flux is 500 watts per meter square. For maintaining the temperature at 32 degrees Celsius, the plate has 2 cross 2 meter, the value of heat transfer coefficient. So you have to find out the heat transfer coefficient. Again we will use the same Newton's law of cooling equation. So what is the equation? Q is equal to HA into delta T. If you substitute all the values in the equation, you will get the value of H, okay, which is equal to 100 watts per meter square Kelvin. You see, Q is given. So what is the Q formula? H into A into delta T. So, but in the question it is given heat transfer per unit area. So you can write this equation Q by A. Okay, so that Q by A I have taken, this area I have taken. So 500 watts per meter squared equal to, then right answer it will become H into delta T only. So delta T is given 32 minus 27. So if you substitute, you will get the value of H, which is equal to 5. Simple numericals only they will ask in the question paper to solve. It will not be going like 2 pages, 3 pages, just 2-3 lines it will be finishing. Okay, so here we found out the H value by using Newton's law of cooling equation. Okay, plus you please remember the formulas always. Next, if Nusselt number is 390, Reynolds number is 39, Prandtl number is 20, then Stanton number will be. So you should know the formula for Stanton number. Stanton number is equal to, as we have already discussed, it is the Nusselt number over the, it is a ratio of Nusselt number over the product of Reynolds number and Prandtl number. So all the things are given. So if you substitute, you will get the value of Stanton number. Okay. Next, in a laminar flow over a flat plate, the convective heat transfer coefficient is proportional to. Okay, so this is one equation you should remember. Hx by k equal to rho v. Actually this is a Nusselt number and this is the Reynolds number. So Nusselt number is equal to this one equation is there. In this H is equal to, you say this is directly proportional to this now. So if you take H is equal to already x to the power of 1 by 2, if this x will go to that side, x to the power of minus 1, then x to the power of 1 by 2 into x to the power of minus 1 will become x to the power of minus 1 by 2. So you please do remember this. In a laminar flow over a flat plate, the convective heat transfer coefficient is proportional. This is for flat plate, not for cylinder. So for flat plate, laminar flow, we are equating Nusselt number and also the Reynolds number. So if you equate, you will get the heat transfer coefficient, which is x to the power of minus 1 by 2. So that is x to the power of minus 0.5. Next, Grashof number is defined as, the formula for Grashof number is, it is a ratio of buoyancy force and viscous force, and the formula for that is G beta delta T LC the whole cube by kinematic viscosity nu square. Just only remember the formula and the definition. Definition is a ratio of buoyancy force to the viscous force. Sometimes they will ask the formula also, which is G Grashof number is equal to G beta delta T LC cube by kinematic viscosity nu the whole square. That is the Grashof number formula. Next, in forced convection, the hydraulic diameter of cylindrical object with diameter d is, okay. So for forced convection problems, for finding out the Reynolds number, we have to use the hydraulic diameter concept. So hydraulic diameter formula is 4a by p. Okay, so for cylinder, area is pi by 4 d square and perimeter is pi by pi d. If you cancel that, you will get the value d. So this is for cylinder. For cylinder, in forced convection type of numerical problems, you have to find out the hydraulic diameter value. To find out the hydraulic diameter, cylinders dh is equal to d, right? And for rectangular, the hydraulic diameter dh is square. For rectangular, it is 2ab by a plus b. For square, it is a, and the answer for this is d. Okay, so the hydraulic diameter for cylinder is d, for square is a, and for rectangle is 2ab by a plus b. So they will ask us, it is a kind of semester based problem, in that you have to solve 2-3 pages. The first step is to find out the hydraulic diameter, but in our question they will ask only the formula for hydraulic diameter calculation. What is the formula to find out the hydraulic diameter in case of forced convection? Okay, this is the formula for forced convection. Next, which of the following condition is correct for natural convection? Okay, these 3 things you remember. Grashof number is greater than Reynolds number square is free convection, and suppose if the Grashof number is lesser than the Reynolds number, then that is forced convection. If Grashof number is equal to Reynolds number, then that is mixed flow. Okay, mixed convection. Here for natural convection, then Grashof number by Reynolds squared is greater than 1. That is this one. Natural convection or free convection, both are same, then this is the answer. So these 3 things you remember is important. Next, free convection flow depends on all of the following but except one. Actually, free convection is depends on some of the following factors. They have given some of the options, but in this one is add man out. We have to list out. We have to find out what is the factor in which the free convection is not depend on. Okay, what are the options given? Density, right? Then what is the another one? Coefficient of viscosity, then gravitational force, then fourth one is the velocity. Okay, so for finding out the free convection, there is one number which is called as a Grashof number. What we have seen, you see, Grashof number is equal to G beta delta T LC cube by nu square. Okay, so here gravity is there, kinematic viscosity is there, or dynamic viscosity is there, and density also will be there. But free convection means there is no velocity. Forced convection only velocity will be applicable. In free convection there is no velocity. So the answer is, for free convection flow, it is not depending on the velocity. It will depend on only density and friction and also that is called coefficient of viscosity and gravitational force. So these are the some 20 questions we have seen in the convection. So previous year so many states also they have asked this type of questions. Okay, thank you.